Okay, here's a little exercise that I want you to do. We need to become familiar with recognizing a graph and its derivative without a calculator, without being given the function. So what I want you to do is I want you to start by finding the derivative of each of these functions. Okay, so pause the video, find the derivatives, write down the functions and their derivatives there in your notes, and then come back for some further instructions. So this first one, very simple, power rule, f prime of x is equal to 3x squared minus 2. The second one, f prime of x is equal to negative 6x plus 5. The next one, f prime of x is equal to negative 6x plus 5. The next one, f prime of x is equal to 4. Okay, e we need to rewrite as x to the 1/2, which means that f prime of x is equal to 1/2 x to the negative 1/2, or 1 over 2 times the square root of x. Now, this last one, you may be thinking, Miss Redmond, how are you expecting me to find the derivative of this? What do we always do with our absolute value functions? We always break them into piecewise functions, right? That's how we deal with them. So let's do that. Let's break this into a piecewise function. Okay, for the left side, we change the signs, and this is when x is less than 3. I gave you an illustration here. This is the graph of the absolute value of x minus 3. Okay, the right side, we keep everything the same. So when x is greater than or equal to 3, it looks like the line x minus 3. All right, so I did this when we were looking at differentiability. Okay, I didn't mean to label that as f prime. I apologize. That is f. Okay. So f prime of x, when we take the derivative of the first piece, it's negative 1. And the derivative of the second piece is positive 1. Okay, so now what I want you to do is I want you to graph each of these functions and its derivative, and I want you to list 2 observations or connections that you see. So that could be graphically, that could be algebraically, whatever connections you see between these functions and their derivatives, I just want you to write that down. Okay, if you don't have a calculator, I suggest using Desmos.com. It's a really good online graphing calculator utility. It'll do lots of cool stuff for you, so you can use that as a resource if you don't have a calculator, a physical graphing calculator with you right now, because I haven't given you all any yet. So pause the video, graph the functions and their derivatives, and list what kind of connections you see. Okay, the big connections that I wanted you to see is, number 1, the reduction in degree. Okay, when you take the derivative, your function is reducing by 1 degree. The other takeaway that I wanted you to make was I really wanted you to just refamiliarize yourself with what these functions look like. What does a cubic function look like? What does a quadratic function always look like? As far as B and C are concerned, I wanted to show you that even though the original polynomial was different, the derivatives are the same. Okay, that's a possibility. You can get the same derivative from 2 similar functions. And then I wanted you to become familiar with the square root function if you weren't already, and what its derivative looks like when that square root's in the bottom. Hopefully you put parentheses around this right here in the denominator if you typed it in that way. You could avoid the parentheses if you use the exponential form, but you would have to put parentheses around the negative 1/2. Okay. And then the neat thing here about the absolute value is this is what its derivative looks like. Depending on where you put your open and closed circle, this is almost always, usually your absolute value functions, their derivatives are negative 1 and 1. It just depends on where your vertex is, where those will change. Okay. But you always end up with these 2 horizontal lines with your absolute value functions. Okay, so I just kind of wanted you to take those away because they love to ask questions like this. Okay, now they don't necessarily ask you to match them, but they do ask you, hey, here's a function. Which one of these is its derivative? Okay. So let's see here. We're supposed to match the functions in A through D, and the derivatives are the 1, 2, and 3. So again, we've got to realize what's going on here. We're not given any functions, so we can't compute any derivatives, but we've got to recognize, oh, hey, A is a quadratic. This is x squared. So its derivative is going to be linear. So it's got to be number 3. Okay, A's got to be number 3. And guess what? D, it's number 3 as well because it's a quadratic, so its derivative is going to be linear. Okay, B is linear. So its derivative is going to be a constant. So B is number 1. And then C is a cubic function of some sort. So its derivative is going to be a quadratic. So C matches with derivative number 2 there. Okay. So A and D there in our example, like I had with B and C in the previous example, that 2 different functions can have the same derivative. Okay, so I want you to practice in the textbook on page 131, and I also want you to add on page 133, I want you to add number 90 to that. Okay, so page 133 as well, number 90, that's a good example of a AP style question there with this idea.